Yeah, so thanks, Stephen, for the introduction. Happy to see you guys. I'm Micah Nebeling. I'm at the University of Michigan. So this is basically my first paper that I did over there. I invite you to visit me both at Michigan, like physically, but also online at our new website that's at the bottom of the slide. So in this work, I'm going to present what I'm hoping to be, at some stage, the new version of a cross-device web browser. It is basically an extension of the work I presented last year at CHI. So last year at CHI, I presented XDBrowser and a couple of examples of what you can do with this cross-device web browser. I want to illustrate here, so you can basically distribute tasks between multiple devices, like a map browsing task, and then view the information differently. You can remote control devices, and all this with a browser, so you don't have to actually install any other kind of Android or iPhone application. XDBrowser basically just uses the browser that you have already installed on your device, and then gives you this power of building distributed user interfaces, or actually browsing existing web interfaces using a distributed approach. Okay, so I mean, I know this is the cross-device session, but I still quickly wanted to give you a quick motivation. So one reason why you may want to have a cross-device interface is actually to join multiple devices so that you achieve larger screen real estate than you would have with individual devices alone. Another reason could be to make better use of devices with very limited input and output capabilities. So we see a lot of studies where they basically give you 10 tablets, but these are essentially just 10 tablets that have the same input and output capabilities. I think there's interesting ways to make use of multiple devices when you, for example, use a smartwatch in combination with a smartphone. And clearly there's this other very prominent use case that we saw in a lot of early cross-device interfaces, basically using one device to control another remotely. And so this work is situated in a body of research that is, it came out of a frustration essentially, where in 2013, 14, 15, there was this proliferation of new kinds of toolkits to create cross-device interfaces, myself included. So I also threw out some of my own toolkits, and I thought, please use them, do something fascinating with them. And you know, all these papers basically just show a couple of examples to illustrate the power and expressiveness of the toolkits. But I never really learned anything interesting about whether users actually want to use those cross-device interfaces. And now we're beginning to see more of these studies like we saw before. And this is the other, and I didn't include your work here, the latest work of yours, but basically there's a wide range also of cross-device studies. And most important to my own work here is actually cross-device elicitation studies. So Calgary had an interesting early one at ITS, and most recently was a number of people, including Hans and Roman, and from the University of Constance, where they did an interesting elicitation study that they divided in two phases, and basically wanted to figure out whether the kinds of interactions and interfaces that people want should be spatially aware. So should the interfaces understand where devices are positioned, or does that not matter? Is it better to have just spatially agnostic interfaces? Okay, so in this work, I wanted to address this gap between the cross-device toolkits that we have on the one side, hoping that somebody will use them, and the cross-device studies that are really trying to generate these interesting findings, whether people would want to use kinds of interfaces. But you know, as I just pointed out earlier, it was interesting to see the visualization interface that you created, and I wanted to push you a little bit harder there. So I need to push myself also a little bit harder. So this is just the first version of XDBrowser here. In this very first version, it was not the browser that I actually wanted to have. It is more like an editing task. So what people do here, or what I actually do myself here, if you can tell from the hair, I'm just trying to distribute this interface so that I can actually browse a Gmail-like interface. I can use my smartphone to check my inbox, but I actually do the reading. I actually consume the information or read the email on the tablet. And so I just split this existing interface, and then I start a synchronization between these devices. And frankly, you can probably not see it very well, but basically now I can remote control the device on the right. So I'm saying that this is not the browser that I envisioned, but it was very powerful and useful for a study that I did in that paper, but it's not the tool that I wanted to build. And why is that? Because it still requires a lot of steps to actually create this cross-device interface, even though you don't need to program. and you can work at the visual level. You don't have to work at the code level, so that's maybe an achievement, but you still have to click and move a lot of things around and actually create this distribution. To actually create the cross-device interface that you see on top, which frankly doesn't do a lot of smart things, you actually have to go through a series of 6 steps. And so this paper, this current paper, is actually trying to make this possible in just one interaction. To make this possible, I wanted to basically learn from my own research, and in this earlier study we investigated a range of interfaces and asked users what kind of cross-device interfaces they would want to create out of these mail, media, maps, article, and slideshow kind of interfaces. And in this earlier paper we then had we essentially found 6 cross-device interface patterns that I named in that paper, and I show some examples of these patterns. And then I was thinking, okay, now that I have these patterns, if nobody else is going to do it, I want to do it myself. I should be able to build this thing that does everything automatically, right? XDBrowser 2.0, I know the patterns, I just need to do some automation. And that was the paper I wanted to write for Kai this year. It turns out we weren't there yet. I had to do more studies. So as maybe a disappointment to you, as much as it was to me, this is a paper that essentially contributes 2 more studies that will help me in the future maybe build this browser. So to contrast these 2 works, because maybe you're also wondering, oh Michael, XDBrowser 1.0, 2.0, how far do you want to take it? Okay, so the first paper was basically asking how do we design cross-device interfaces and how users would want to design them. And this one is now trying to investigate how can we automate cross-device design so that maybe in the future, since we don't have cross-device developers out there, we can maybe use tools that do some of this more automatically. So this new work also starts basically from the earlier research where I found a category or 3 categories of cross-device patterns. So copy and sync patterns, so you copy elements between devices and you keep them in sync. Remote control and view and input are 2 patterns that I described, and I show some examples in a video, that are move and sync patterns. So you basically move elements from one device to the other, so they disappear on one device and they appear on the other, and then you keep them in sync, and you have interesting remote control or view plus input interfaces that way. And the last category of cross-device patterns that at least I described in my work are asynchronous. They make asynchronous use of multiple devices. And it turns out that these are the patterns that are the most difficult to automate. It's just really hard to guess what people want to do, and that is one of the findings of this paper as well. So I want to do the presentation of this paper a little bit backwards. I show you first what I think is the kind of XDBrowser 2.0 that I wanted to build. So, and this was also used as a prompt in this study. So by default I use a duplication kind of cross-device. What happens on one device duplicates on the other. Very simple, the devices are in sync. But then, as soon as the user decides to perform some interaction that I don't know yet, it would automatically create this cross-device interface, right? So we zoom the element that the user invoked on one device, and then as the user can perform the same interaction to cancel, basically, and restore the original interface. What looks the same maybe to you now, these are actually 2 different kinds of cross-device patterns that I just started. One was remote control, and I'll explain a little bit. So the study was really asking, so what are the interactions that people would want to do? What would they want to do? What's the star here? So that people can actually, so do they want to cut things, and what kinds of gestures do they want to do? To actually create this kind of remote control cross-device interface. And another example that I'll follow up through in my presentation is an overview and detail pattern. So if the user instead interacts with another element here, which is actually not a control, it's actually in this case just a reading pane, the intention could be to produce the overview and detail pattern. So what's the interaction for that? And then how do we actually produce this interface? Okay? And now, it's not super technical, but if you're interested as a web developer, I'll dive a little bit inside. So to answer this question, we actually need to find these components. So this is segmentation, okay? So you see the visual interface here. As the user interacts with this interface, we need to look behind the scenes. So we look at the HTML and also the CSS and maybe what happens with the JavaScript. And then we want to actually find this component. That's not trivial to actually find this component, and it doesn't always work. So I don't present this perfect solution today, but at least we have a first algorithm with which we can work. Okay, we're trying to answer this question in this paper, and the other question is also then if we interacted with this element instead, we know from the other work that something else should happen. It should produce the overview and detail pattern. And here it's a bit tricky because none of these elements actually have a lot of characteristics or features that, if you will, that we can work with to actually produce it, but we actually need to find this component, okay? So I'll take you to through the first study, which is really trying to answer the question of what are the interactions? It's an elicitation study, essentially. What are the interactions that users would want to use to produce these cross-device interfaces? I describe a lot of this in detail, and I want to convey a little bit how the study was designed. So we basically had different reference, or basically different prompts to users, and we were showing them the cross-device interfaces that we wanted to produce, and we were asking them what interaction should produce that interface, okay? So we looked at different types of cross-device patterns, basically all of them that I described earlier in my 2016 CHI paper. So these are overview and detail and view and input as two of the examples. An interesting aspect of my earlier work was that people wanted to be able to very quickly switch between patterns, and so we also asked what would be the interaction for that. Remote control is another example of a pattern. And split is one that is an asynchronous use of these interfaces. What I do here is I'm browsing basically the same location, but I'm viewing different, I'm using different kinds of map information. One is a satellite view and one is terrain view. And parts of this should be in sync, but not everything, and that's a tricky interface to create, actually. And then a typical extend pattern where you basically extend one interface to the other, in this case used to actually investigate a cross-apps task, so that it happens a lot that you get emails and they want calendar things, students want to schedule things with you, and then you're just using one device, so you need to switch between the mail interface and the calendar interface, and since this was a little bit investigating these cross-apps tasks. The study also, each of these interfaces was basically studied under different conditions, and these conditions were a different set of multiple devices. So we looked at phone and tablet, which was also the device configuration that I looked at in my earlier work, but then I was also interested in what's the role of smartwatches, and what if we just take away the tablet and we just give you a smartwatch instead, how would users react, okay? And that caused interesting adaptations to the suggestions, and that's also part of the finding of this paper. And then we brought in the tablet again, and we were wondering, so how would you adapt your suggested interactions again? So there's a lot of this discussed in the paper. The HighLevel results are basically, so they produced 161 interactions in total across these 6 tasks for each of these 3 device settings. So there's not too many super surprising novel interaction techniques. It's just similar interaction preferences. A lot of commonality with the work from Constance. So that was not necessarily the point, but in some sense it's confirming your research, so that's also maybe cool. My users wanted everything to be done automatically. It should be as simple as just clicking and then magic, okay? Expecting browser to determine the desired pattern. That was a strong theme. It was not like, oh, I'm going to do and drag this and then some spatial super interaction. It wasn't like this. I just want to double tap and that's it, okay? You do the magic, Michael, and I'll try it, okay? Changing interactions to fit devices combinations. That was an interesting, there's a lot of detail in the paper. As I varied the configurations of devices, you could see different kinds of interaction proposals. So that is something those of us who do elicitation studies, we need to pay a lot of attention to the kinds of devices that we're using, whether it's just all tablets or whether it's different kinds of devices, and what the effects of actually changing device configurations could be. There was, in my paper at least, or in my work, especially as I introduced the 3rd device, there was this strong trend to just make it spatially agnostic. It became very difficult to think spatially, 3 devices, and how do they reference each other? From the smartwatch, do I mean the tablet or do I mean the phone in the middle? And so people just changed their interactions accordingly. Overall, a trend towards a little bit contradicting your finding, Roman, but that's something we need to look at in more detail. And there was also the shifting roles as I, reintroduced the tablet. Suddenly they were not constrained to smartphone and smartwatch anymore. There was a reshifting of the roles. Basically, there's the desire to just use the largest device to make it as comfortable as possible. But you can actually play around with this effect of actually introducing different kinds of devices, and then you would see how I could see interestingly, and it's described in more detail in the paper, how the users actually shifted roles. And maybe as a result of the legacy bias that was discussed earlier, In my study, users were actually hesitant to expand to more than 2 devices. And I just want to make this point here because I get this a lot from reviewers. We don't know whether people need to have 6 devices to complete the task. It's not like we need to find a way to prove that 6 devices is the right way to have it. Maybe 2 is just enough. Maybe it's just enough. Another way to ask it is maybe we don't, if we have multiple devices, maybe we could start building more complex interfaces that really push the boundaries. And that's what I wanted to mention earlier, just to connect also to the research that was presented earlier. So the second study is essentially trying to automate this and using humans because there's a lot of semantic stuff in my patterns that are difficult to just write code. So I actually hired 3 students. They were very familiar with the patterns that I described earlier, and they tried to apply these patterns, manually segmenting the top 50, basically top 5 from 10 carries from the Alexa top 50. Labeling, in the end, 41 pages, producing about 1,000 labels so that we can actually learn a little bit more. And then we went through a semantic analysis to understand really what are the differences between the 3 students. Why did they sometimes pick different elements? Did they actually pick different elements, or are they just visually different, but they are the same nodes, or are they actually really different? So this is what I discussed in the paper as well. I want to rush a little bit through this, just basically saying that we were able to automate some of the patterns more easily, and it became very difficult with the asynchronous use patterns. One of the patterns that we were able to automate the most easily was the view and input. It is very easy to find input controls in the web interface. They just have the same widgets. They look like text. They look like forms, basically. Very easy to find this both visually, but also going through the HTML in some sense. We struggled with other patterns, and I discussed this in more detail in the paper. The remote control pattern was interesting. We could automate it most of the time, but there are interesting ways to actually to actually implement interfaces that are not always compatible with the algorithm that I have in the paper. And there was like so little agreement when it comes to overview and detail, and it had to do with just, you know, let's say you look at YouTube, is the detail actually the description of that video, or is the detail actually the video? The detail that you want to zoom in. And so that is an interesting thing that we saw. As a quick takeaway, I'm wrapping up. The page segmentation that I describe in more detail in the paper works like this. We observe an interaction, we look behind the scenes, we're trying to find the element, we define some criteria. In this case, we find a control has an on-click handler, but we define it in a way so that we would find a larger element that actually wraps a number of these, and then we actually zoom this. We identify this as an inbox element, we zoom this, and this is what it looks in action. You saw this before. So we find this element, we zoom it on the other device, we apply the cross-device pattern. And so this is basically what I was able to do with the studies. The main takeaways are basically we elicit these preferred interactions to trigger and switch between these patterns. If you noticed, I didn't really tell you what the most popular interactions were, but I thought that was not the most interesting takeaway because it changed all the time. Learned which patterns can be automated and where are the issues. Developed a new prototype that does part of it at least. And we actually then also started to test with existing kinds of popular sites where we ran into all kinds of interesting issues. But overall, I would still claim we have some promising results. Okay, I will leave you here, and thank you for your attention. Payback.
Payback time. No, I think it's really, really great that our work builds upon each other, and I think that's really cool. And I think this fact that you mentioned that in your study there was much less spatially aware but more spatially agnostic suggestions for the interaction is really interesting. I think we should look into that. That's very interesting. So one thing that I wanted to ask, the problem with the elicitation studies, at least when we did them, and I think it's often documented in literature, is that they, exactly like you mentioned, the users expect magic. They do the same interaction over and over again and then believe the system can somehow interpret why this time something else should happen. Do you have a rough estimation how many of the suggestions that you got were conflicting in that sense?
That is interesting. So I tried to resolve. I mean, within the proposals there were definitely conflicts, and if you know other parts of my work, I'm actually very, very interested in embedding into elicitation studies a kind of like, let's see whether we can actually implement some of this as we are actually eliciting. I did this with Kinect analysis, a little bit of an earlier work. Anyway, so basically through agreement, we eliminated some of these conflicts. I would say that there were, for some users, you couldn't actually implement their particular gesture set, but overall, we eliminated it through like agreements and maximum consensus. We applied some of these techniques to actually find one that can be implemented, and that's the one we implemented.
Okay, and since there's no one else, I can just add another comment. So adding to this discussion is too enough. I think what we might, I think maybe we are doing a small mistake there by comparing apples and oranges, because we have very different tasks. So if you look at a visualization task, it's well documented that multiple views make a lot of sense. I mean, the whole info with textbooks are full of it, like multiple coordinated views linking